All right, we're going to take a look at force 4.3, which is understanding different forces that affect motion. There are 4 forces that affect motion: gravitational, frictional, normal, and tension. Right now I'm going to focus on the concept of gravitational. The objective states that you need to demonstrate how gravitational force, or weight, can be calculated from mass. Explain that gravitational force, or weight, of an object is proportional to its mass. I think the first thing that we truly need to understand is that gravitational force really is weight of an object. A lot of the times, and I've said this in class, people explain mass and weight as interchangeable quantities, but that's absolutely not true. So I'm going to give you a little example here of how we would then calculate our gravitational force. The first thing that I need to do is I find the mass of my object, so I chose a calculator since I'm already going to be using it, and the mass of my calculator is 89.8 grams. Now, 89.8 grams is in fact a mass, but in physics we use the concept of kilograms, so I'm going to show you how to convert those. All right, you might remember from class the old kangaroos hop down mountains drinking chocolate milk. So I'm going to use that method for you here just because it's an easy conversion, and then I'll show you mathematically how we can do this as well. So I know that I have 89.8 grams, but I want to convert them to kilograms. So I'm going to look at my my grams here, and I know that I need to get to kilograms, which are over here. So I'm going to move my decimal once, twice, 3 times to the left to get to kilograms. So I'm going to take my decimal once, twice, 3 times to get it over here, fill my empty spot with a 0. So now I have 0.0898 kilograms. And that is the true mass of my calculator when we're talking in terms of physics. Now, an easy shortcut, if I know I had to move my decimal spot 3 times, I'm looking at 3 zeros or 3 place values. So I could just take my 89.8 and divide by 1,000, and I would get my 0.0898 kilograms. So anytime you have a gram measurement and you want to convert it to kilograms when you're talking about mass versus weight, you can just divide by 1,000 to get the value that you need in kilograms. Now, we need to figure out what the weight of my object is. So to find that weight, I actually need to figure out what force is acting on my object. And we know that the gravitational force due to gravity, or force due to gravity on Earth, is going to be 9.8. And they represent that 9.8 either as newtons per kilogram or as 9.8 meters per second squared. The reason I can represent this both ways, if I take newtons divided by kilograms, I know that a single newton is equal to kilograms times meters per second squared. So if I divide that by kilograms, or per kilograms, I would actually be canceling out my kilograms and I'd be left with meters per second squared. So if you're looking at this top value, you would be saying something like 9.8 newtons per kilogram is the force due to gravity. If you're saying 9.8 meters per second squared, you're saying acceleration due to gravity, meaning if something falls to the ground, that's the rate at which it's going to accelerate. Either one is totally acceptable. When we talk about weight, we typically talk about newtons per kilogram, and I'm going to show you why. So looking ahead to the next few objectives, you can see that if I want to find force, I would multiply by mass and acceleration, which we've talked about in class. Or if I want to find the weight, I would take mass times gravity. These equations are exactly the same as each other. For this particular example, I do want to find my weight, so I'm just going to use this one because it makes a little bit more sense. I know that the mass of my calculator is 0.0898 kilograms. And I know that gravity, or the force due to gravity, is 9.8 newtons per kilogram. Well, if I simply multiply those two things together, my 0.898 times 9.8 then I get the weight of my object is 0.88004. I'm just going to leave it as 0.88 so it's a little bit easier. So I multiplied these two numbers together, and I got a weight of 0.88, and I can call that newtons. Because I have kilograms, and I'm multiplying by newtons per kilogram, so if I were to do that, my kilograms would actually cancel, and I would be left with newtons only. So you can see that no matter what object you have, whether it's a calculator or some other object, all you have to do is multiply it by the force due to gravity, which is constant on Earth, 9.8 newtons per kilogram, and you're going to get the weight of that object. You will notice that it's in newtons, meaning that that is force due to gravity. So weight is gravitational force. It's a really long word that I just had to write there, and I'm running out of whiteboard space. So, anytime you say the word weight, you are saying gravitational force. Anytime you say the word mass, you are talking about the amount of matter in an object, and those are clearly two different things. As the mass of the object goes up, the weight of the object would also go up. Because look at that, mathematically, if I multiply a bigger number by the same value, it's going to go up. So you can see that the mass of the object is proportional. If mass goes up, that means that force due to gravity, or gravitational force, is also going to go up, or the more gravity is going to be pulling on that object.